Hi guys, this is Mrs. Gastler, and in this video we're going to talk about isotopes. We're not going to talk about average atomic mass, that's in another video, which you can watch later. Alright, so to begin with, an isotope, the word isotope refers to a particular atom, okay? And what it means to be an isotope is this. We say that an isotope of the same element. Okay, sometimes we could talk about isotopes and be talking about different elements, but when we're talking about an isotope of the same element, they have the same atomic number. And hopefully you remember that the atomic number tells you the number of protons, but they have a different, which I should have written that on all caps too, but I didn't, mass number, okay? And then to think about that, remember that the mass number is protons plus neutrons, okay? And since the protons have to be the same, in order to get a different mass number, we need to have a different number of neutrons. And so an isotope of the same element has the same protons, but a different number of neutrons. So if you change the number of neutrons, you are talking about a new isotope. Generally, the electrons are the same, but it really just kind of depends. We'll put a sometimes on that one, okay? So let's talk about what this looks like in terms of the element or the isotope name and symbol notation, and I'm going to try and cover this up a little bit. Okay, so here I've got two isotopes. These are isotopes of the same element. I can tell because they have the same element name, but they have a different mass number. And remember, this is element name, and then after the dash, it's not a minus, it's a dash, is the mass number. Okay. So if I know what the element name and the mass number are, I can know how many protons, neutrons, electrons each of these guys has, okay? Carbon on the periodic table is number 6, so it has 6 protons and 6 electrons, unless it tells me otherwise. Both of these have 6 protons and 6 electrons because they're carbon. Carbon tells me the protons. Now, this guy has a mass number of 12, and so 6 plus something has to equal 12 to get my neutrons, and so that is 6. So this guy has 6 neutrons. But over here, 6 plus something has to equal 14, so the number of neutrons is not the same. This time, I have 8, okay? Now, before we draw some Bohr models, let's look at this atomic symbol notation. We wrote this one. This is the isotope name. Down here, this is the symbol notation, we called it, okay? And remember that here is the mass number. This would be the electrons, and sometimes we leave that off. Actually, no, the charge goes there. That 6 shouldn't be there at all. Never mind. Okay. This would be the atomic number here, okay? And if we didn't know that, we could look it up from the element symbol right there. Okay, so these guys, they say the same thing. So here's carbon 12, this is carbon 12. This is carbon 14, this is carbon 14. This is just what it looks like. Notice that they have the same atomic number, but different mass numbers. Now we already figured this out. They both have 6 protons and 6 electrons. And this guy, to have a mass number of 12, has to have 6 neutrons. And this guy has to have 8 neutrons, okay? So that is the number of protons, neutrons, and electrons. When you're drawing the Bohr models of these atoms, we're going to put the protons and the neutrons in the nucleus, okay? They both have 6 protons, but remember that the difference is in the neutrons, so I put 6 here and 8 here. That's where the difference is in the Bohr model. They both have 6 electrons, so that's going to look the same. 2 on the first level, and 1, 2, 3, 4 on the second, so that I have 6 altogether. And so that's what the Bohr models look like. The only difference is in that neutrons right there in the middle. Okay? One other kind of question that you're going to see is something like this, where you have to identify which ones are the same element. Okay? And remember, to be the same element, they have to have the same protons. Okay, so we're looking for the two with the same number of protons. P for protons, that's going to be particle 1 and 3. If we were looking for them to be isotopes, okay, then we have to make sure that their neutrons are different. So we're looking for them to have different neutrons, which these guys have. So just to give you an example, if this one said, let's go with 5 here. If this one said 16 protons, but it had 19 neutrons, okay, and 20 electrons for some reason, okay? So 16, these are the same element, but they're also the same isotope. So they're not different isotopes of the same element. They're the same isotope of the same element. One just has more electrons than the other. So that's what we're looking at here. It's got to have the same protons and different neutrons. But all three of these, we'll give that a 5 too, and this would be either 1 and 3 or 1 and 5, okay, for the different neutrons, the different isotopes. Okay, so that's what we're talking about when we're talking about isotopes. If you have any questions, isotopes are really cool. We don't show all the isotopes on the periodic table because it would be ridiculously big, but I'll show you that in the next video about average atomic mass. Thanks for watching.